So today we are going to do two problems on change of state and calorimeter. The first question is, heat is supplied at a uniform rate to a piece of ice. The melting begins after 2 seconds and is complete in the next 20 seconds. Calculate the initial temperature of ice. Now, in order to do this problem, you have to understand that the ice was at a temperature less than 0 degree. For the first 2 seconds from that temperature, the temperature of the ice came to 0 degree, and in the next 20 seconds, the temperature remained at 0 degree, but the ice melted, right? And the melting was complete in that 20 seconds. So, and that 20 seconds, no change of temperature took place as it was a change of state. During change of state, temperature does not change. So, first, let us supply heat at a rate of x calories per gram, and let us take the initial temperature as T. You can also take it as minus T, but if you can take it as T, there will be no issues. So from first 0 to 2 seconds, what happened? Heat was supplied to the ice to take its temperature from T degrees Celsius to 0 degrees Celsius. So that amount of heat is mass of the ice into its specific heat into 0 final temperature, which was 0, minus the initial temperature T which we have taken, and that is equal to 2x since heat was supplied at the rate of x calories per second and heat was supplied for 2 seconds, so 2 into x. Again, for the next 20 seconds, which means from 2 seconds to 22 seconds, what happened? Heat was again supplied to it, but the temperature did not change. The ice melted into water, and this was done using latent heat of fusion, and we all know that latent heat of fusion is equal to 80 calories per gram. So mass of the ice into 80 calories per gram will give you the amount of heat supplied during the next 20 seconds, and this will be equal to 20 into x, because x was the amount of heat supplied per second. So the heat was supplied for 20 seconds, so it is 20x. So now if we divide the two equations, s is equal to 0.5 in case of ice, it is not 1 as in the case of water, it is equal to 0.5 in case of water. So if you divide the two equations, m into 0.5 into t equals to 2x divided by m into 80 equals to 20x, you will get t is equal to minus 16 degree Celsius. T is equal to minus 16 degree Celsius. Had you taken T as initial temperature as minus T degree Celsius, you would have got a result T is equal to 16 degree Celsius. T is equal to 16 degrees. So your initial temperature was minus 16 degree Celsius. Hope you understood this problem. So our next question is, 20 gram of water at 70 degrees Celsius is mixed with 20 gram of ice at minus 10 degrees Celsius. What is the final mass of water and ice and the final temperature of the mixture? Specific heat of ice is given as 0.5 and latent heat of fusion of ice is given as 80 calories per gram. Now, in this type of question, first, what you have to do, you have to calculate the amount of heat required to reach 0 degree by both the components. For example, the amount of heat required to take ice from minus 10 degree to 0 degree, that is equal to 20 into 0.5 into 10, that is 100 calories. And amount of heat required to take water from 70 to 0 degree is equal to 20 into 1 into 70, because specific heat of water is 1. So, and this is equal to 1400 calories. Now you can see that the amount of heat in water, is more than that of the amount of heat in the case of ice. So water will supply heat to this ice in order to convert it into water at 0 degree, right? Had the case been opposite, which means if the amount of heat required to take ice from -10 degree to 0 degree would have been greater, then the water would have been converted into ice by that ice. Understood? So this is 1400 calories. So out of this 1400 calories, 100 calories will be used. 100 calories will be used to take the temperature, to take the ice from -10 to 0, right? And the rest 1300 calories will be used to convert ice into water and at 0 degree. Understood? So what will be the amount of ice that will be converted into water? What will be the amount of ice that will be converted into water? We know 80 calories is the latent heat of fusion. So amount of ice that will be converted to ice, amount of ice that will be converted to water will be equal to 1300 divided by 80, and that will be equal to 16.25 grams. So amount of ice in the mixture, amount of ice remaining in the mixture will be equal to 20 minus 16.25, that will be equal to 3.75 gram, and amount of water in the mixture will be equal to 20 plus 16.25, that will be equal to 36.25 gram, and the final temperature of the mixture is 0 degree. Now, an important point is that why is the final temperature 0 degree? It could have been 10 degree or it could have been -5 degree. Yes, it could have been, but then the amount of, had it been more than 0 degree, suppose it is in between 0 degree and 70 degree, then it was, that final temperature was possible only when the water had enough heat to convert the whole of ice into water at 0 degree and then raise its temperature to that final temperature. But that water didn't have that amount of heat. So if I tell you, if I do a simple change, instead of 20 instead of 20 gram instead of 20 gram, if I take 100 gram, if I take 100 gram of water, then what would have happened? Amount of heat required to take from 70 degree to 0 degree, that would have been 100 into 70, which means 7,000. This would have been 100. This would have been 100. This would have been 100, right? And this would have been 7,000 calories. So this 7,000 calories, which will be much more, this 7,000 calories, let me cancel it. This 7,000 calories is very much heat, and this 7,000 amount of heat required to melt. Now amount of heat required to melt 20 gram of ice into water will be equal to 80 into 20, that will be equal to 1600 calories, right? And so total amount of heat required to change ice at minus 10 degree Celsius to water at 0 degree is will be equal to 100 plus 1600 equals to 1700 calories, right? So this 1700 calories is the amount of heat which will be received by ice, and now the temperature of this amount of water will be raised to a final temperature. Let that final temperature be T. So heat received will be equal to this 1700 plus 20 gram of ice at, now it has been converted into water, so specific heat 1 into T minus 0 into T minus 0, which will be T. Okay, so you see that this is the total amount of heat received, right? So total amount of heat received is this, and heat lost will be equal to, let the temperature, final temperature be capital T, so heat loss will be equal to 100 gram of water into specific heat into 1 into its final temperature of 70 minus capital T. So if you now equate these two, heat lost according to principle of calorimetry, heat lost is equal to heat received, right? Heat lost is equal to heat received. So this will be equal to 20T plus 1700, 20T plus 1700 will be equal to 7000 minus 100T. 7000 minus 100T. So from here, you can easily find out 120T is equal to 5300, and therefore T will be equal to 5300 divided by 120, and you can calculate the value. I am not calculating that degree Celsius. Okay, so this is how to do these type of problems where there is a mixture of water and ice. I hope this helps you in your studies.